Hello again, my dear teachers and students. Try to recollect the previous experiment. We worked on an experiment related to light traveling from rarer to denser medium. And beyond that, we also addressed the concept of refractive index. In this experiment, we are going to work on light traveling from denser to rarer using water as the denser material and air as the rarer material. But before that, I want to briefly address the concept of refraction. I'll only touch upon the surface so that we can go deeper through the experiment. Now, why does light bend is the serious question that we need to address. When does light bend? When it is traveling through a single material or when it changes from one material to another. That is one thing we have to address. Now, imagine light is traveling in air. It always travels in a straight path. Okay, but when it travels from one material to another material, we say that light bends at the interface. So we need to address why this is happening. So let's look at our example of water and air system. Let's say water is in the bottom, air is in the top, and light is traveling from water to air. So this is what light is doing, and it is traveling from water to air. In this scenario, we can clearly see that light is traveling in a straight path as long as it is inside water. Now, why does it bend when it goes into air? That is the question I am trying to address here. There are two reasons for that. The first reason is speed of light changes whenever there is a change in material. In water, light is a little slow, whereas in air, light is a little fast. As density of the material increases, here we call it as optical density. As the optical density of the material increases, light becomes slow. It has more disturbances to handle, and more the matter, slower the light. Compared to water, air is less denser. Here, light travels in a much more faster way. Still, air has some molecules which are loosely packed and all those. But if light travels into vacuum, it is the fastest over there. So let's think of it in the reverse way. In vacuum, it is the fastest. In air, it is a little slow. In water, it is much more slow. And finally, in glass, it would be much more slow. So here, if you observe, velocity of or speed of light in water is less, and whereas speed of light in air is more. So this is the first reason why light bends, because there is a change in speed. Here it is slow, but as soon as it goes to the other side, it is faster. That is one reason. And second reason, very important reason is light prefers path of shortest time. Light prefers path of shortest time. So light doesn't care if straight path is the one that takes us to a destination. Our common sense tells us that straight path is the shortest time and shortest path. But not really. Whenever there is a medium change, there is a good chance straight path might be slower. So light bends because a bent path will take it to its destination in a faster way. So in this case, please observe this. At this location, I am drawing a normal. Here we have denser medium. In the top, we have rarer medium. So as light travels from denser to rarer, it does not travel in its original path. This is its original path. Instead of going in its original path, it goes away from the normal. This is the normal, which is always taken as 0 degrees. So instead of going in a straight path, it bends away from the normal. So that is the key concept here. And why is it bending away from the normal? Two reasons. Because its speed has changed when it entered into air. And second reason is it is traveling in this path due to this path is its shortest time. It is its shortcut. If it goes in this path, it would take more time for light to travel, whereas in the other side, it is a shorter path. Let's take an analogy for this. Imagine this is a highway or a very like a road which has too much of traffic over there. You are here and you need to go there. Now imagine there is a side road somewhere here. Another road which is not used much. You have two options. You can travel in this road where there is enormous amount of traffic. It will take you more time to travel in this road. But if you take this shortcut, you can travel to your destination much more faster. So light prefers shorter time than shorter path. Okay, this is the whole introduction. But before I proceed to the experimental procedure, I have a table to write. Let me write the table and then we can do the procedure. So I am going to write the table on the board right now. So as I was saying, we have a similar table like last time. We have incident angle and we have refracted angle. Here too will not take a lot of degrees, like very few, 0, 10, 20, 30, 40 and 50 degrees. Beyond that, it becomes tough to handle. Now, incident angle corresponds to water as the material and refracted angle corresponds to air as the material. So as you can see in the table, incident side is the denser medium and refracted side is the rarer medium. So with this background, let's get started with our procedure. So here are the material for our experiment. I am calling it the refraction disc. We made it with plastic. Your textbook says metal. There's a reason why they wanted metal, because they want to dip it inside water so that it sinks a little bit. But this one would float, but we will be holding these hangers for that. Now, as you can see, there are lots of angles over here. This is the interface. 90 degree is the interface. Below this will dip it in water and above it will be in air. And see this is the 0, 0 line. You can see 0 here and 0 here. That is our normal line. Now for example, if you keep it at 20, observe carefully. Let's call this the bottom straw. Let's call this the top straw. When I keep it exactly at 20 and 20, is it appearing in a straight line or not? Both the straws. Please check. This straw and this straw are making a straight line. Obvious, because you are seeing both of them in air. It's the same material and you already know light travels in a straight path in a single material. Now I am going to dip this in water, but before that, let's establish a logic of doing this experiment. Now imagine this is the one straw, let's say the bottom straw, this is the top straw. From where should you observe these two straws? I can't use my head position right now, they are not making a straight line. So what I should do, rather, I should close one eye and move a little to the side and make sure my eye maintains a path in a straight line between the two fingers. So this is my bottom straw, this is my top straw and this is my eye. All three are making a straight line. This is how we have to observe. Now let's try the same thing over here. Now I am placing this refraction disc in a beaker filled with water. You can also use a bucket. I am placing it in. It's very important to pour water till the interface, the 90 level. So that is extremely important. Make sure you do that. That will reduce your errors if you pour it the correct level. Now look at this. Do you still think they are making a straight path? See the bottom one and the top one. The two straws are forming like a tick mark. It's not making a straight path because light is traveling from water into air. So this will make it bend a little bit. Now let me move this straw so that you can see when it makes a straight path. Tell me, is this correct direction of moving? I am moving it towards the normal. Am I making it straight or am I making it more curved? In fact, you can see it's becoming much more curved. So when light travels from denser to rarer, I should not move it towards the normal. In fact, I should move it away from the normal. And I will stop it as soon as I feel that both the straws are approximately making a straight path. For me, this is what seems to be perfect. For you who is observing on your screens, this might not be perfect because your viewing angle and my viewing angle is different. So observe me for a second. How should I observe? Now please observe. Your viewing angle is from the front. The perfect viewing angle is my position. I am closing one eye and I am observing the bottom straw. And I am adjusting the top straw so the bottom and the top straws are making a straight path with respect to my eye. If you do it in this way, you will get the best results possible. So everything is in a straight path. So for 20 degrees, I am getting an angle approximately 25 degrees. So simultaneously, let me do another angle, that's 30 degrees. Now please observe, it's still making a tick mark over here. And now I am adjusting the way I have told you. And my head position is in a way, so all the three things, the bottom straw, top straw and my eye are making a straight path. For 30 degrees, it is showing approximately 39 degrees or close to 40 degrees. Now let me pull it out and I want you to clearly observe what happens. Now observe over here. Check this. This is the bottom straw position which is inside water. And this is the top straw position which is outside water, that means air. Now see this, this is the incident angle, that is 30 degrees, and look at refracted angle. It bent away from the normal, so from instead of normal it bent away and it is showing 39 degrees. So as light travels from denser to rarer, it bends away from the normal. Next I will write the remaining results and we will discuss the observations and conclusions. Let's analyze these results. Look at this. Incident angle is smaller than the refracted angle, which proves that light bends away from the normal. Okay, and I have stopped at 50 because if I do it at 60, there is a good chance it might cross 90 degrees also. That concept is called total internal reflection. In the next experiment, we are going to address that. But now look at this again. Imagine this is your incident ray. Let's say this is 30 degrees and the refracted angle is not 30 but a little more than 30, that is 39 degrees. So what did we prove in this experiment? As light travels from denser material to rarer material, it bends away from the normal. You might think this experiment is very simple. Yes, it is simple and it also has historical significance. This is one of those experiments, that means water and air system experiments, where Indians and Greeks, ancient Indians and Greeks performed this experiment. Why am I specifically telling you about ancient Indians and Greeks? The reason is these two communities or these two civilizations, they did not prefer physical experiments much, that means using materials and all. They always preferred mental experiments, thought experiments. So this is one of those experiments where they have used materials to find a law. Okay, the law of reflection, where light bends away from the normal or light bends towards the normal in a different scenario. So this one has a history of more than 2000 years. And thank you for listening. Let's meet for another experiment.